Alright, so hopefully you got kind of an idea after watching the Khan Academy video as to what a differential equation is and kind of an introduction to it. Basically, what you need to understand is that a differential equation is an equation that contains an unknown function and some of its derivatives. Now, there are different orders of differential equations. The order of a differential equation would be the highest order derivative within the differential equation. We're not going to go that far into this. There's an entire class that you could take in college over Diffy Q. We are just going to look at ones that we've actually already looked at and how they relate. So you could think of, like for instance, a first order differential equation could be something along the lines of y prime equals f of x. And those are the types of functions that we have dealt with. An example of this would be if I told you that y prime equals x cubed. Well, then the solution to this we've already found. We know that the solution to this, to find the y, the equation y that works for this, would be the antiderivative then of y prime to get what the solution would be for this. And we know that y prime would equal x cubed. So this is just one type of differential equation. Now, this solution is actually a family of solutions because depending on what the C is, we could have an infinite number of solutions for this. Generally, we don't want the general solutions. We usually would like what is called the initial, with an initial condition, we use initial value problems. So we find like an actual solution, not just general solutions. All right, for example, if I told you that the derivative of z with respect to x was 10x to the third plus 2x minus 1. And I asked you to solve the differential equation if z of 0 equaled 5. So that's your initial value. All right, well, we know that this means that we've taken the derivative. So if we want to know what the original function, just z, was, we need to find the antiderivative. So that'd be 10x to the fourth over 4 plus 2x squared over 2 minus x plus c. So now I'm going to go ahead and simplify this down a little bit. We would have 2.5 x to the fourth plus x squared minus x plus c. And I know that my initial value is going to be z of 0 equals 5. So z of 0 would equal 5 means that if I plug a 0 in for each of these x's, then I need to get 5 for my answer. So therefore I know that c would be 5. So my final function, z of x, the original function, was 2.5 x to the fourth plus x squared minus x plus 5. And that is a solution for this differential equation of the first order. All right, we're going to do one more example and then we'll be done. This next example, let's say that I have dq to dy. So I would challenge you to think about what that notation means. And I'm going to say that that equals 7 cosine y plus 3y. And my initial value would be for q, when q is 0, it equals 10. All right, so our solution, to find a solution for this differential equation, we need to find a q such that when q of 0 equals 10. Well, since this says I took the derivative of q with respect to y, I can go ahead and take the antiderivative of q, or of q prime with respect to y. So this is going to be 7 sine y is the antiderivative of 7 cosine y, plus 3y squared over 2 plus c. And I know this says that when I plug in 0, I get 10. Well, q of 0 would be 7 sine 0 plus 3 halves 0 squared plus c, and that's supposed to equal 10. Well, I know this goes to 0, this goes to 0, so c must equal 10 in this case. So a solution, or the solution to this problem, to this differential equation, would be, Q of y equals 7 sine y plus 3 halves y squared plus 10. And again, these are very, very simple differential equations, but just want you to understand that a differential equation is an equation that has an unknown function in it as well as any number of its derivatives within the function or within that equation. All right, we will do some more of these together.